Assalamualaikum and good morning. My name is Aida Mustafa and today we are going to look at one exercise for association rule mining. Now, what it does is, it is one of the data mining tasks whereby it will mine association rules from large databases. Now, we are going to use this example from the BICE computer dataset. So basically, in association rule mining, we represent the data set in terms of transactions. So for example, we have the first instance or the first transaction whereby if a person with age less than 30 but his income is high and he is not a student and his credit rating is fair, then he will not buy a computer. If we have a look at another example, if a person has the age between 31 to 40 with very high income but not a student but still with the same or fair credit rating, most likely he will buy a computer. Okay, so basically this examples is available in many of the books. Now, what we are going to do today is to see this example and how do we use it, or we use this data set for associative building an associative classifier. Now, the question says, given the training data below, build an associative classifier model by generating all relevant association rules with support and confidence threshold of 10% and 60% respectively. This means we are looking at supports 10% or 0.1 as well as confidence amount or confidence value of 60% or 0.6. Basically 60% means it appears 6 from the total 10 transactions. So in this case we have 14 transactions, 60% is like 10 out of 14. So then we want to classify this model using a new example. So this would be our so-called testing set. So we want to know if we have a person with age less than 30 but his income is medium and he is a student and his credit rating is fair, so whether or not he will buy a computer, that is what we are going to predict using associative classifier. Okay, so now let's have a look at solving this question or this exercise by using a priori style association rule mining algorithm. Now, how are rules generated by the priori style rule mining algorithm? How are frequent item sets are used when we want to create rules? Now, for each frequent item set, we have to create all possible rules that contain all the items in the item set. Then, for each rule, we compute the support, which consists of all attributes of the rules, over and divided with the support with attributes that occur on the left-hand side, which is the confidence of the rules. Now, we want to keep those rules who are confident is above the confidence threshold. So in this exercise, our threshold values, if you remember, the support is 10%, and the confidence value, we are looking at 60% or 6 out of 10 transaction. So let's have a look at the solution here. Now, the first step that we want to do is we want to map the attribute values as the following, because the original data set is too much to write, so we want to represent the attributes with values. So let's say we have values age, we have attribute age, income, student, and credit rating. Now, for attribute age, there are 3 values. The first one is age, the category age less than 30. The second one is age between age 31 to 40. And the third one is age above 40. The same as income, variable, we have 3 different values which are high, medium and low. You can cross-check with the data set in the previous screen on the example. Next, we have student variable, which only has 2 values, which are yes or no. And finally, we have credit rating variable, which has 2 values as well, which are fair and excellent. Now, we are going to represent this as new symbols, because it's just too much to write when we want to generate the rules later. So for the first one, we will represent with A, B, C, income, high, medium, low. And then for student, true, student, no, this is we use T. And credit rating fair, we use F. Credit rating excellent, we use E. So next, we represent all the transaction as in available in the question. So let me pull that back on. Okay. So let's check. The first transaction is AHTF no. A, if a student has age less than 30, right? And then the income is high. He is not a student, and the credit rating is fair. And finally, he will not buy a computer. So basically, you take every row or transactions, and we represent in this form. Okay, let's continue. So the first one, the first step, there are 2 steps in association rule mining. The first one, we want to find the frequent item set. The reason we want to find frequent item set, because we don't want to deal, we don't want to end up generating rules for item set that are not frequent. This is called item sets. So we don't want to, for example, if the variable age less than 30, if it occurs below our expectation, below our standard threshold, which is 10% in our case, then we don't want to bother calculating them all. Okay, so the first one, what we'll do is we have all these items and we want to find the support. Okay, so let's say the first one, for a candidate class yes, we have the support 2. This one, if we are looking for item A. Okay, for item A, class yes, for item A, class no, the support is 3. What does it mean actually? So we have to have a look. Oh no, it's okay, we can use this one. So we have to find, again, we have to find the frequent item set. So these are all the items. Okay, now A is an item, B is an item, C is an item. Now we want to find frequent item set that has support more than 10%. Okay, so given this, the first item, but the class is yes. So we are looking for item A. From this list, we have 1, 2, 3, 4, 5. We have 5 items. Am I right? Oh no, I missed some. 1, 2, 3, 4, 5. Yeah, that's correct. So between these 5 transactions that contain A, which one will lead to class yes? So let us count again. So this A go to no, this A go to no, this A goes to no, this A goes to yes, 1. And this A also goes to yes. And there are no more A's. So for item A that leads to class yes, the support is 2. You okay? Now we will do the same with class no. So basically we have 1 here, item A but leads to no. We have item A leads to no, that's 2. This is 3, item A leads to no. Yeah, that's all. So we have support 3. Okay, so we continue on finding the support for all the items. Okay, so we have A, B, C, say A, B, C, H, M, L, S, T, F and E. Now, don't worry about this. I think I put it. It's not consistent. This is uppercase. I'm using lowercase here. No problem. So after we count all the support, how many times? Basically, support is how many times the item appears in the transaction. Recall, this is one row is one transaction. Okay, so we have 14 transactions here. So because the support threshold is 10%, we are going to have a look at 1 and more, isn't it? No, we are going to look at 2 and above, because we don't want to take 10%. So 2, yeah, we'll take 2, 3, 4. This is 0, whereby there is no transaction consisting of samples aged between 31 to 40 that does not buy a computer. So that's 0. We cancel that out. And we continue, blah, blah, blah. Then we have this one, L. What is L? Okay, a person with low income but doesn't buy computer. We have only one in the transaction. So we cross that out as well. And we cross this one. What is S? S is a student that does not buy a computer. Okay, so leave that. So after we've done the first round, the first cycle, we have identified what are the items that appears more than 10% from the total transaction. Next, in association rule mining, we want to generate all the item sets, all possible rules. Okay, so before that, we need to generate the item. So what we do is we have this. We are going to look into the combination of 2 items. So this is all one item. Now we are going to look combination of 2 items. Okay, so AH class yes. This means is there a person with age less than 30, but with high income that buys a computer. So again, we have a look here, and we again we calculate the support, the frequency of the items or the frequency of the items appearing in the transaction. So we have combination AH class yes, 0, AH class no, yes, and then we go for BH. Okay, BH yes, we have 1 here. Let's have a look at BH and yes. Here we also have this one, this transaction. So the total is 2. Okay, then we go have a look at 2 items. The rest of it, we have CH, no, CH class yes, no, CH class no also. That means, this means there are no transaction consisting the combination of item C, age greater than 40, as well as high income. Okay, so in this data set, basically everyone age greater than 40 has medium or low income. Okay, whatever. So then you go through the list and you will find all this support. Okay, and you go on until here, blah blah blah. Right, so let's have a look. Now it looks like a lot to calculate or to write, but it is actually very straightforward, because it is just simply taking in or counting in the support and then later the confidence of the rules. So again, we do this for 2 item set, HF, combination of HF, combination of MF, ME, LF and LE. Okay, after we've done that, again we cross out those that has confidence value, support value 10% and below. So we want to cross out 1 as well as 0. Next, we want to go for 3 items in 1 item set. Okay, so we have a combination of AHT class no equals to 2, ATF class no equals to 2, and then we have a look. Remember, if it doesn't appear, if we have dropped or crossed out the frequent items in here, that means we do not have to generate the three item set. Okay, 3 item set, meaning there are 3 items, 1, 2, 3 in this item set. So we do this, and finally, after we've done all the 3 item sets, we want to generate for 4 item sets, but then none exists. Okay, so we are done with the first step, which is generating the item set. Now we want to generate the rules. Okay, don't worry about it. Now let's see the classification of rules. So you have now, we are going to look at the one with support more than 10% only. So we have the first rule generated is AHT class no. Okay, AHT class no, and then we have ATF class no. Okay, then we have CMF class yes, and then we have LSF class yes. Okay, so the rules are basically, now we want to find what are the confidence of the rules that we generate here. So for the first one, if a person has the age less than 30 and his income is high and he is not a student, then the prediction for him to buy a computer is no. So you have to find back AHT in the original transaction. Okay, so what will happen, we have these rules, AHT, ATF, CMF until LSF, that comes from this table. Again, we want to find the support and the confidence. Now, these are the rules generated. So, for example, the first item set AHT, again, we have to check back. Let me pull back the original data set. Okay, oh no, we'll use the example on the previous page. Okay, now it says here, the class for AHT, no, the support is 14.3%. 14.3, it means 2, okay, which is this one. So 2 divided by 14, the total transaction, you get 14.3%. Now we want to have to access or to calculate this is the confidence of the rules. Again, these are all rules. We want to calculate the support and the confidence. Now we have to go back and look at the transaction. How many transaction that has A, H, and T with the class no. Okay. So we go back here. We have here AHT class no. AHT class no. Do we have AHT class yes? AHT yes? No. That means it is 100% because 2 out of 2. Okay. Let's have a look at the next one and the other one. For example, this LSF. LSF has the support 14.3%, which is this 2 out of 14. 2 divided by 14, we get 14.3%. Now we want to have a look what is the confidence value for item set LSF with, what is it? With class yes. Okay. So LSF yes, 1, LSF, anyone? 2. Okay. Is there any LSF but no? There's none. So this is 2 divided by 2. So we get 100%. So the first part of rules here, you take from this table and then you continue, backtrack to all the way the table that you have here. Okay. So that's why, let's just pull one. For example, what is this? Let's take the last one here. CS. Okay. So CS, a person with age greater than 40 and he is a student but the class is CS. So let's have a look at the support. CS, yeah, we don't have CS here, maybe the previous page. CS. Okay, found it. So it is here, the combination of CS. The support is 2 because it appears from here, CS. Let's see, CS1, CS2. So it appears in 2 out of total 14 transaction. So we have, where is it? Oh, we are looking at this. Okay, so the support is 14.3%. Now we are going to find the confidence of it. So let's have a look. Let's go back to the table just now, to all the transactions just now, and see how many transactions that contains item C and S that leads to class CS. Okay, so we go back here. How many items, how many transactions that contain C and S? So we have 1, 2, C and S. And this one, 3. Is there any more? No. So we have 3 transactions that has item C. What is it? C and S. I have such a short-term memory. Yep, C and S. So I have 3 transactions that contains item C and S, C and S, C and S. However, between these 3, only 2 that leads to yes. CS, yes, and this one we have CS, no, and then we have CS, yes. So basically, the support is 2 over 3, which is 66%. What we have here. Okay, so you continue doing that until we go to the final one. Then after you've done everything, you just cross out those confidence below than 60%. Okay, for example, this one, item E that leads to no, the confidence is just 50%, so we want to cross. So basically we get 66%, we have 75%, 85%. So these are all the rules that are generated. This is the second step. Now, but the question asks, where is it? Where's the question? Okay, but the question asks, so those are the 2 steps in association rule mining. First, you calculate the support, and then you generate all the rules. Sorry, the first one, you find the frequent item set by calculating the support. The second step is you generate all the rules, and you only pick rules with the confidence value above certain threshold given by the question, or given by the owner, or whoever decides to do this data mining process. So, but the third part in this question is this. The question says, classify using the model, using all the rules that we have generated just now. Classify using this rule the new example. So this is like a test case. Now, if we have a person with age less than 30, his income is medium, he is a student, and his credit rating is fair. So we want to select rules with the highest confidence. Okay, so we go back to the solution here. Now, this is the test case, or the test example that the question asks. Age less than 30, income is medium, student yes, credit rating fair. Now, there are 9 rules. Remember, these are all rules that we have generated. And from the set of rules, there are 9 rules that apply with the X above. There's no red here because this is printed black and white. Okay, so you can see this 1, 2, 3, 4, and there are more in the previous page. So basically, we rewrite all the rules here. For example, let's have a look at the last one. Sorry, F class CS. What is F just now? Oh, credit rating is fair. Okay, now credit rating is fair. The class is yes. Okay. Credit rating fair, the class is yes. This one, 42. Okay. Corresponds to this. Okay. So, we extract all the rules that are related to the question or to the test set that is given. Then we want to find with the highest confidence. Okay. So, these are the confidence values: 100%, 100%, 85, 75, 66, yeah, 60. So the highest confident value predict the class yes. So in this case, highest confidence 100%, see, predicts yes, 100% predict yes. Yeah, that's the highest one. Okay, so in this case, given this test case, the highest confident rule will predict a yes. That means in association rule mining in the question, basically we will predict that this person will buy a computer. Okay, so this is another way of using the voting technique. So if we use voting, there are 7 rules predicting class yes. So combined confidence is 81.27%, and there are 2 rules with class no. See, class yes 1, 2, 3, 4, 5, 6, 7. Okay, so this is using the voting technique, whereby you want to vote which class that will win, whether yes or no. So in this case, we have 7 rules predict yes. So basically, yes will win. The one that we have here is basically just ranking the confidence rules. Okay, so we're done for this. I'll see you in the next video. Bye.